Physics in the Flesh. Let's do another conservation of mechanical energy problem. The roller coaster car shown below is dragged up to point 1 where it is released from rest. Assuming no friction, calculate the speed at points 2, 3, and 4. So what you're looking at here is a classic conservation of energy problem. You've got a roller coaster, various heights, and you have to find either the height or the speed. In this case, you have to find the speed. Classic conservation of energy problem. Okay, so we are told in this problem, we're given this picture, the height of the first point is 36 meters, and then we've got 2 here at the bottom, 3 is at a height of 29 meters, 4 is at a height of 16. So using that information, we can just go ahead and say, you know what, let this be h equals 0, and everything's measured relative to that. So because I want to solve this based on conservation of energy, I'm going to first extract some important information from the problem. And that is that it's dragged up to point 1 where it is released from rest. Okay, so I know here that V1 is equal to 0. Okay, and that's going to help me a lot to simplify my expressions later on. Okay, my H1 is 36 meters because that's the height I'm at right now. So H1 is 36 meters. And what I want to do is write something like this for every single point. For example, at point 2, I don't know what the speed is, so V2 is equal to question mark. But I know that H2 is equal to 0 meters, right? At point 3, I know that H3 is equal to 29 meters, and I'm looking for V3. And similarly for point 4, I know that H4 is 16 meters, and I'm looking for V4. So yeah, you might think it looks redundant, but this is really organized. It helps you see what's going on in the problem, what do I know, and what am I looking for. Okay, so let's go ahead and jump right into our conservation of energy expression. ET1 equals ET2. The two types of energy we're dealing with here are, again, gravitational potential and kinetic, just like in video 109. So EG1 plus EK1, EG2 plus EK2. Go ahead, plug in the expressions. mgh1 plus 1/2 mv1 squared equals mgh2 plus 1/2 mv2 squared. Okay, so just like in the previous video, I have mass appearing in every single term. So I'm going to cancel that out right away. And the other thing I can do to simplify is noting that V1 is 0. Okay, notice that right now I'm just comparing points 1 and 2. Okay, so V1 is 0, so therefore this entire thing goes away, and I'm going to be left with GH1 is equal to GH2 plus 1/2 V2 squared. So let's come up with an expression for the speed down here because that's what I'm looking for after all. And notice that you have a g on the left. Well, actually you can factor that out. You can factor out the g. So let's actually do that first. G h1, bring this one to the left, minus h2 equals 1/2 v2 squared. Then isolating for v2, you're going to have to multiply both sides by 2 and take the square root. And I'm just going to write v2 on the left to make it look a bit cleaner. 2g h1 minus h2, and then you square root the entire expression. Okay, so there's my expression for V2, and actually this is going to come quite in handy when I solve for the other speeds as well. So this is the main formula that I'm going to stick to. Of course, I can just plug in the numbers now to figure out V2, but I'll use this for the other parts as well. So V2 equals the square root of 2g, so 2 times 9.8 meters per second squared. H1 minus H2, so H1 is 36 meters, H2 is 0, 36 minus 0 is 36 times 9.8 times 2 square rooted. You put all that in your calculator, you are going to get V2 is approximately 27 meters per second. So there you have the first speed. Now we can go on to do the other parts, but we don't have to do this much work. We just start from this point. Just notice that whatever speed you're looking for, you put that height in that spot right here. And you can just use H1 as the other height. Okay, so let's go ahead and do V3. So V3, therefore, is going to be equal to the square root of 2g H1 minus H3 this time. Okay, so again, plug it in. 2 times 9.8 meters per second squared. H1, 36 meters minus H3, which is 29 meters. Simple math, just plug it in your calculator. And when you do that, you're going to get the V3 is about 12 meters per second. So we're almost done. We have one more to do. I'm going to do my V4 right here. So V4 is equal to the square root of 2g H1 minus H4. Okay, so plug in your values. Square root of 2, 9.8 meters per second squared. H1 is 36 meters. H4 is 29 meters. Sorry, no, H4 is 16 meters. Okay. Plug it in, punch in your numbers, and you're going to get V4 is about 20 meters per second. Okay, so there you have it. You figured out all your speeds. Now, just step back for a second, make sure your answers make sense. Because this is conservation of energy, it's an exchange between gravitational potential and kinetic. Okay, so just looking at the picture, because, for example, point 1 is the highest height, it needs to have the lowest speed, which is 0. Okay, now notice point 2 is the lowest point. It should have the highest speed. So in terms of speed increase, it should be 2 is the highest, then 4, then 3. Okay, in the case, 2 is the highest, then 4, then 3. So your answers make sense. Always a good check to do in physics. Guys, that's it for this video. Be sure to subscribe to Physics in the Flesh if you haven't done so already, so you can always be alerted of the new videos I post every weekday at 12 noon. Smash that like button as well if you enjoyed the video. Otherwise, guys, I will see you tomorrow at 12 noon for video 111, Law of Conservation of Energy 1. Hey guys, that's it for this episode. If you enjoyed it, be sure to check out some of my most recent videos posted over there on the right, which you can click on your screen right now and watch. Other than that, guys, I hope you enjoy the rest of your day, and I will catch you in the next video. Is the end screen too long this time? Wait, you're still recording? No! Oh. Gotta move that chair out of the way next time.